Hello, how is it going? Welcome back. This is Gennaro Washington here, CEO of Coitech Solutions, and today we're going to be talking about network security fundamentals. Brought to you by ACSMI. Let's get started. Network security. By far, one of the other important things that I would say would be good to really understand in depth. Without the network, security would not exist. What I mean by that is, well, if you don't have a foundation of networking, at least understanding the groundwork, at least understanding what ports and protocols are, it's going to be a little bit harder to understand how security fits into it all. Remember, the main pillars here of cybersecurity are confidentiality, integrity, and availability. What we're really saying here is that in order to protect our networks against threats and all these different threat actors and nation states and pretty much everything that we talked about thus far, we have to be willing to understand that, hey, there's always going to be a threat. There's always going to be a vulnerability. How can we go about protecting that? And using these advanced techniques such as zero trust and behavior analytics, understanding these basics is going to be really crucial to having a good foundation and understanding how to really basically have a strong defense, right? To defend against these different threats. The OSI model. Please do not throw sausage pizza away. That's the way I learned the OSI model. Now, there are many other ways you can learn it. I mean, it really just depends on what fits best for you. But that's the way I learned it. And that's what stuck with me because I love pizza, okay? All right, now let's break it down a little bit. The physical layer is all about your physical devices, cables, ports. It makes sure that the devices themselves, at least from that physical standpoint, is protected from any type of tampering. Data link layer is all about, switches. Switches operate on layer 2, which is all about MAC addresses, but this helps prevent MAC address spoofing. Now, data travels from the physical layer all the way to the application layer and then back again as it receives it. So think about it like that. And understand that what we really are looking to utilize, like for instance, TLS, that we're using the transport layer. This ensures that confirmation, the transformation, or at least the aspect of going from, okay, I am now bits, ones and zeros, all the way to the aspect, okay, I can actually see the application layer now. I can see my browser now. That's what we're talking about. So understand that there's a whole communication that's happening here. Encryption is happening. The aspect of understanding that you have web application firewalls, ways to protect the organization, that data that we know so much about. Firewalls. Now, we know that at the core aspect of a firewall, it's all about what can I allow and disallow within the network. Plain and simple. But now you have next-gen firewalls. Now we're taking it a step further. We can do advanced filtering now. We can filter on encrypted traffic, inspect it. You can also do deep packet inspection too. The aspect of doing a next-gen firewall is, we're trying to take it a step further. We have the ability to identify malware and threats, and even block certain threats from happening with IPS capabilities, intrusion prevention capabilities. So IDS and IPS, we talked about it before, so I won't talk too much in depth on this, but just know that IDS is all about detection. And IPS is all about, now I can stop this. I can prevent this from happening. There's also a difference between signature versus anomaly detection. One of the great examples I like to look at it is you have your virus signatures a lot of times, and you have your malware, which could be heuristic, which could be polymorphic. It can change. So it's not really going to rely on a signature because it doesn't really mean much to it. It can change. It can change its makeup upon execution. So now you have antivirus and anti-malware solutions integrated in these systems. Let's talk about VPNs. Oh, a VPN, virtual private network. Now please, don't go to your local Walmart or your local hospital or your local McDonald's and try to use the Wi-Fi for banking information. I wouldn't do that. Solely because it's not a crime in a sense to have Wireshark up passively. Now, if you interact with that and you actively take that data and you do something with it, that is absolutely illegal. But that's the thing. If we know, we could do better. So when you're using a VPN, you're using protocols such as IPsec or OpenVPN, and you have the ability to do split tunneling where you can route the actual traffic that's going to be going from your work system to your corporate network. And then you can have the other data going for just public, right? You can bypass all the other stuff. Zero trust framework is basically saying, hey, we're not going to trust anybody. No user, no entity, no device. We're not going to trust you. We're going to verify you, though, to make sure you're good. The core principles around this are going to be least privilege. Like we talked about it pretty much before. Like we really only want to give them the information that they need. And that's it. That is all we're going to give them. Nothing more, nothing less. All the permissions. That's it. And to continually verify with multi-factor authentication. Because yes, every time they log in, they have to say, okay, well, I have my code. I have my one-time password. I have my something that I am. Something that I know, something that I have, right? We're doing multiple factors of authentication. When we're segmenting a network, what we're saying here is that I'm not going to allow people in VLAN A to talk to VLAN B unless you specifically allow that. But you have to do that within the configuration piece on your switch. This reduces the aspect of lateral attacks, which is basically stating that you may have 5 Windows 10, Windows 11 systems, and they all have the same build, and then the network have the same thing. Well, if you didn't patch a certain patch or a new vulnerability came out on all 10 of those systems, then that leaves open the room for a vulnerability and an exploit for that vulnerability using a lateral movement. But if you have network segmentation, this lessens that aspect. Having secure configuration on an actual, here's an example. Let's say you have a Linux web server that you set up, and within that you decided to use Apache web server. Well, that Apache web server is going to have a config file. So you can absolutely modify that config file to your liking. So you want to change the aspect of using default credentials, especially after you deploy it. You want to turn off external USB interfaces on laptops to prevent tampering, because anyone can just plug in their USB, and we don't want that. The integrity of your systems, it really solely depends upon what type of security you have on the endpoint. That's why we have EDR now, endpoint detection and response. We can in real time detect something happening and then respond to that. That's usually how it is. Some organizations, they also have what's called SOAR, security orchestration, right? Automation and response. So think about it like that. Or you can have more of a SIEM with the capability of real-time alerts. APT is as simple as this, and we talked about it before. This is a group, usually, of individuals that know what they're doing. To be quite frankly, they know what they're doing, okay? They can sit in your network without you even knowing for a long time. Studies show that APTs can literally sit in your system for 6 months plus, and you not even know it. They'll go as far as patching your devices, they really will, to eliminate them from being detected, or that, hey, it's working perfectly fine. I passed all my things. I was able to patch my system. But a way to attract these APTs are going to be honeypots. These are specifically designed systems to be vulnerable, right? So you attract someone, and then you analyze what they're doing, their TCPs, their tactics, techniques, procedures. Let's talk about a real-world example here. Well, you have secure remote work with VPNs, and we talked about this before as well. So think about it like this. You have your system, you're at home, and you're wanting to act or interact with the corporate network. Well, you're going to use a VPN. It's going to be a tunnel, okay? An encrypted tunnel. No one can say it's out this tunnel. You want to use protocols such as OpenVPN and IPsec like we talked about earlier, and then you can configure split tunneling for that speed and accuracy that you would need. And privacy too, especially now if you have a work laptop, and I would say you would only use it for work, but if you have a personal laptop and you want to do all these things, and you have VPNs, sure. Of course, it's going to be according to policy of the organization. But if you have a strict, just laptop for work, you really don't have to worry about that. That's all you access is the content within the organization, and that's it, you're good to go. So another one is going to be, if we're looking at deep packet inspection, I talked about this earlier, you have tools out there that's going to detect the threat. You have tools out there that's going to allow you to really hone in on more of the information that's available to you, right? We want to be able to see a little bit more past than what's usually there, all right? But it's been great. Gennaro here, CEO of Cortex Solutions, and we've just been talking about network security fundamentals brought to you by ACSMI. I do hope you have a great day, and I look forward to talking with you soon. See you in the next one. Take care.